Hi, this is Amitav Majumdar. You are invited in the class of Edunguru. So, we will be having the chapter today, mole concept. First, I will start with Dalton's atomic theory, since Dalton was the first person who gave us the structure of chemistry. So, we should salute him and we should start with his theory. First, he stated that matter consists of smallest indivisible particle called atoms. Try to understand, that is smallest indivisible particles. Second, he said that all atoms of a same element have the same mass. That means if I talk about, for example, let us say it is a nitrogen atom, another nitrogen atom always will be having the same mass whatever the source may be. And he stated that two different elements, let us say nitrogen and let us say oxygen, will have different mass always. That means he said that two elements cannot have the equal mass, always true. Third, he said is that when elements combine to make compounds, the elements combine in the small whole number ratio, because in those days very less number of compounds were being discovered. I am talking about 1808. So, that time let us say they discovered carbon dioxide CO2, where carbon is one atom, oxygen is two atoms. For example, CO, carbon monoxide, carbon is one atom, oxygen is one atom. That is the ratio of the atoms where small whole number ratio is stated. So, these were basically the concept given by Dalton. Later on, we found that in today's world basically all those theories proven to be wrong, but still we salute Dalton because he gave the concept of chemistry first. Now, if we talk about the first point, atoms, he said it is the smallest indivisible particles. Atoms have basically electrons, protons, neutrons, bosons, positrons, so many particles inside. So, atom today's world is not indivisible, it is divisible. Second point, if we see that same element will have the atoms of the same mass, in today's world it is found to be different. That is, we have come to know the isotopes. So, what is isotope? Isotope is basically 17Cl35 and 17Cl37. So, here you can see that 17 is basically the atomic number and 37 is basically the mass number or number of neutrons plus protons, and the 17 is basically number of protons. Similarly, 17Cl35, here 17 is the atomic number, 35 is the mass number. It means that chlorine 17Cl35 has got mass of one atom as 35 AMU, and 17Cl37 one atom has got mass 37 AMU, even their atomic numbers is same. Since their atomic numbers is same, so therefore both the atoms are basically chlorine, but have different masses. One is 35 AMU and is 37 AMU. Other examples also we can say that 1H1, 1H2, 1H3, that is hydrogen, deuterium, tritium. In that case, everywhere atomic number is 1, that is number of protons is 1 or number of electrons is 1 in the atoms, and the mass number you can see that is hydrogen, tritium it is 3, deuterium it is 2, hydrogen is 1. So, these are basically isotopes. So, therefore, isotopes are basically having the same atomic number, but different mass number or different masses of the atoms. I would ask you, what is the definition of isotope?
Sir, atomic number of element is same, but mass number is different.
So, mass number is different, atomic number is same. Very good, excellent. Now, we will go to the another concept of isobar. What is isobar? See, as I was telling that two different elements can have different mass, true, but again two different elements can have the same mass. Like for example, if I write X, A, let us say Y, and I am writing Z, B, Y. Here you can see that atomic number X and atomic number Z is different. So, therefore, A and B are two different elements. Since their mass number is same, so therefore, this is basically they are isobars. So, therefore, here A and B elements are isobars. So, I can ask you the question, what is the definition of isobar? The definition of isobar will be the atomic number of two element is different, mass number is same. So, as I said that number 3 point stated by Dalton was basically that he said that atoms combine with simple whole number ratio. So, actually in today's world we get so many polymers, so many interstitial compounds, so many different types of compounds in which you know that this does not follow. For example, if I talk about Fe 0.930, it is an interstitial compound. If I talk about a polymer, let us say for example C1015H223, let us say oxygen 352, right, for example. So, this is a polymer. So, in this case you can see that here the ratio is 0.93:1 in the first compound, in the second compound is 1015 is to 223 is to 352, it is not a simple whole number ratio. So, therefore, it is now proven wrong, but still we should salute Dalton because he gave the structure of chemistry. Next we will go to laws of chemical combination. Just now we finished Dalton's atomic theory, and looking at Dalton's atomic theory, laws of chemical combinations came one after another. First given by Lavoisier, a big scientist, and he said that law of conservation of mass. Now, in law of conservation of mass, what he actually stated? He stated that mass cannot be created, mass cannot be destroyed. This is one way of approach. Another approach for the chemist, it can be like mass of reactants will be equal to mass of products. Yes, it is true that mass cannot be created, mass cannot be destroyed. For example, C plus O2, if I talk about, it is giving you CO2, then it is 12 gram. If I say carbon is combining with oxygen as a combustion reaction where it is 32 gram oxygen, obviously it will produce 44 gram CO2. So, mass cannot be created, mass cannot be destroyed. But if we take in the line that mass of reactants is equal to mass of products, then it may not hold true properly. Why? Because we have one concept of limiting reagent. So, if I talk about limiting reagent, then obviously we cannot say that amount of mass of reactants reacted is equal to mass of product. So, limiting reagent makes a kind of adjustment of the law. So, therefore, if we talk about the only the mass of reactants equal to mass of products, then we have to think of that it has to be rectified. But if I say total mass is always same, then it is correct. Mass of reactants may not be equal to mass of products. Yes, that will be equal when all reactants have reacted in equal proportion and then it has converted to the product. So, obviously, mass of reactants will be mass of products. For example, C plus O2, we know that it is giving CO2. So, it is 12 gram, it is 32 gram. So, therefore, you get 44 gram of CO2. Now, for example, I have supplied amount is different. Supplied amount is, let us say it is 6 gram and it is let us say 32 gram. If I supply from outside, so in that case how much CO2 will be produced? It is not that 32 plus 6 38 gram, no. So, how we can calculate this? For example, look over here, required amount is 12 gram for carbon, 32 gram is the required amount of oxygen. Here it is only supplied carbon is 6 gram. So, that means what? It is half of the amount actually required from the balanced chemical reaction, that is 1C plus 1O2 gives you 1 CO2. Simple example, simple calculations can take you to the broader calculations. So, over here if I supply 6 gram, the C 12 gram can combine with 32 gram. So, 6 gram can combine only with 16 gram. So, that means what? This will be minus 16, this will be minus 6 gram. So, you get 16 gram oxygen balance, 0 gram carbon remaining, that means no carbon, and it will convert to 22 gram of carbon dioxide. So, I will get 22 gram carbon dioxide, 16 gram oxygen left and 0 gram carbon is, that is no carbon is present. So, that means over here we see that carbon is less in extent compared to required of oxygen. So, therefore, carbon is the limiting reagent over here, here carbon is limiting reagent, and oxygen is basically excess reagent. So, this kind of questions comes in examinations. So, limiting reagent if we consider, then obviously mass of reactants cannot be exactly equal to mass of products. Yes, if whole the reactants have reacted, then you will get the total mass of the product equal to total mass of reactants. But it is finally true that mass can't be created, mass can't be destroyed. So, next law will move on, that is law of definite proportion. It was given by scientist Proust, and it was stated as that any compound, if you consider, will always have the same ratio of their masses, that is the mass ratio of the elements making the compound, whatever their source may be, if it is earth, it is moon, anywhere from the galaxy, if you bring here in the laboratory, if you see the mass ratio of the elements always will be fixed for a particular compound. If a compound is fixed, then mass ratio of the elements is fixed. Let us look at the particular theory. Fe 0.930 is a compound in which iron is not in +2 or only in +3, it is mixed. So, it is a mixed oxide basically, and you have to understand that, and we have found that mass of hydrogen by mass of oxygen, that is equal to 1/8 from moon sample, and the sample from earth is showing mass of hydrogen and mass of oxygen ratio is 1/8. It means that hydrogen oxygen's mass in ratio in both the cases same. So, therefore, the compound is, we can say, let us say H2O. Let us say H2O. Here hydrogen is 2 gram, mass of hydrogen divided by mass of oxygen is 16 gram, it gives you 1/8. So, that means what? The sample of moon and sample of earth is same, since their mass ratio is same. But today we have come to know that it is not again always true. This law has got flaw. How we can prove that? Just look at, let us say for example NO2, and it is basically paramagnetic. Why you call paramagnetic? Because this electron, we can say this is unpaired electron. So, it is in the orbital called sp2 hybridized orbital, and this nitrogen electron is unpaired. So, therefore, if there is an unpaired electron in a molecule, then it is basically called paramagnetic molecule. What is the mass ratio of nitrogen by mass of oxygen? Is equal to 14 divided by 32, that is equal to 7/16. What is NO2? Number 1, it is a brown colored gas, and number 2 is basically paramagnetic. That means it is attracted by magnetic field, it is paramagnetic. Now, if two NO2 molecules is brought together, see from room temperature we are bringing down to lower and lower temperature. So, what happens? They come close by, then make bond, and this bond becomes N2O4, and you know, surprisingly in N2O4 molecule unpaired electron is lost, it is not there. So, it means what? N2O4 is diamagnetic, since there is no unpaired electron, it is colorless. Now, let us see what is the mass ratio of nitrogen and oxygen. Mass of nitrogen by mass of oxygen over here is 14 plus 14, 28 divided by 64, that comes again 7/16. Now, look, what Proust stated is that whenever the compound is same, mass ratio of the elements is same. So, that means reverse should be true. If the mass ratio of the elements is same, compound is same. But here we are proving that this law has got flaw, that if you talk about NO2, it was a mass ratio of nitrogen oxygen was 7:16, and in N2O4 it is mass ratio as 7:16 to a different compounds. N2O4 we can talk about as dimer of NO2, that is 2 molecules of NO2 has dimerized to give you N2O4 molecule. Third one, law of multiple proportion, it is given by again Dalton. He said that two elements, yes, when they make 2 or more than 2 compounds. So, 2 elements should make 2 or more than 2 compounds. So, then what happens is that with fixed mass of one element, the mass ratio of the other element combining with that the fixed mass of that first element will be at a simple whole number ratio. So, that means what? First thing is that we have to focus at these 2 elements. Let us say N and O. Look over here, N and O can make 5 types of oxides. Let us say N2O, it is your NO, it is your NO2, it is your N2O3, it is your N2O5. So, first is nitrous oxide, N2O is a laughing gas, NO is nitric oxide, NO2 is nitrogen dioxide, N2O3 nitrogen sesquioxide oxide, dinitrogen trioxide, and N2O5 is dinitrogen pentoxide. Over here, see again I said 2 elements, so we are confined with 2 elements in NO. Now, mass of nitrogen and mass of oxygen, and the first compound is how much? It is 28 gram, it is just 16 gram. Here in the second compound NO, this is basically 14 gram and 16 gram. In NO2, it is 14 gram and 32 gram. In N2O3, it is 28 gram and it is your 48 gram. Now, in N2O5, it is 28 gram and 80 gram. So, look, variations of the masses of nitrogen in different compounds. So, what he stated is that in this law basically that you fixed mass of one element. Let us say I am fixing the mass of nitrogen and combining mass of oxygen, we have to check out. For example, let us say 28 gram, the lowest mass is 14 gram, so I will make it 14 gram. So, in N2O 14 gram nitrogen can be with 8 grams of oxygen, and second compound NO is basically 14 gram and it is a 16 gram, and in a third compound NO2 it is 14 gram, 32 gram, and in the fourth compound N2O3 it is 14 gram, which can combine with 24 gram of oxygen, and you can see that in the last compound N2O5 it is 14 gram and it is your 40 gram. Just look at, I have fixed the mass of nitrogen at 14 gram. So, we have to again come back to the law that what is stated is that with fixed mass of the same element, combining mass of the other element will bear a simple whole number ratio. You can easily see that combining mass of oxygen is basically 8 is to 16 is to, it is a 24 is to 32 is to 40. It means that 1 is to 2 is to 3 is to 4 is to 5. So, what is that? The simple whole number ratio in terms of mathematics. So, law of multiple proportion has got validity, but again we must say right at this point that yes, this law has got again flaw. If we take the abnormal compounds like interstitial compounds, for example, where is the flaw? Fe 0.930, I am taking 3 compounds of iron and oxygen. Fe, it is your, let us say FeO and let us say Fe2O3. Try to understand. Over here, it is 0.93:1, it is 1:1, it is 2:3. If we calculate with fixed mass of oxygen, you will find that mass ratio of iron with fixed mass of 16 gram oxygen is not simple whole number ratio. You can easily check it out. We can see that it is just like this. We can calculate that combining mass of iron atoms basically how much, we can check it out. Just look at first compound is basically Fe 0.930 and second compound let us say Fe 0.930. So, mass of oxygen is equal to 16 gram, with iron it is basically 0.93 into 56 gram of iron. FeO, if you see that it is 16 gram oxygen and it is your 56 gram iron, and Fe2O3 you can again check that it is, let us say it is 48, that means 48 gram, then if I did by 3 6 and 16 gram, if I add, then it has to be 56 into basically 2 by 3. So, do you think that this ratio is a simple whole number ratio? Not at all. How much it is? Now 0.93 is to 1 is to 2 by 3. So, it is not a simple whole number ratio. So, therefore, yes, with the advancement of era, advancement of science, we have seen that different types of compounds have come into picture. For example, Fe 0.930 is the interstitial compounds. We will see later on that in Fe 0.93 specialty is what? In that Fe plus 2 is present as well as Fe plus 3 also is present. It came in once in IIT exam, IIT joint entrance exam, that what is the percentage of Fe plus 2 and Fe plus 3 in Fe 0.930 compound. So, all of you have understood that laws were being propounded at in the time 1700, 90, 1800, but still we salute to the laws. But as I told you that this question came in IIT, that is Fe 0.930 is a compound in which iron is not in +2 or only in +3, it is mixed. So, it is a mixed oxide basically, and you have to understand that oxygen's charge on oxygen atom is -2, which we can call as oxidation number. So, it is total iron atoms, that is all 0.93 moles of iron should give the charge +2. That is the clue basically to solve that, because question was basically percentage Fe +2 and percentage Fe +3 in moles. They asked this question basically, that Fe cannot be only +2 or only in +3, it should be mixture of both +2 and +3. So, how we can calculate this question? Let us say this iron +2 exists in the compound as x moles. So, it will be Fe +2 will be obviously 0.93 minus x moles. So, you need one equation only, that is what? Now, x into charge of iron is +2. So, I will write +2 plus 0.93 minus x into iron's charge +3 plus oxygen atom is 1 atom. So, the 1 into -2, that is equal to 0. So, just solving this question you can get that 2x plus 2.79 and minus 3x minus 2 equal to 0. So, you can go like this, that is 2x minus 3x is minus x, and that is equal to minus 0.79. So, therefore, x equal to 0.79 moles. So, that means number of moles of Fe +2 is 0.79 moles. Yes, Isha? So, that means what? What is there? Then percentage. So, along with that we can also calculate the Fe +3, that is nothing but 0.93 minus 0.79 moles, that gives you number of moles of Fe +3, that is equal to how much? 0.14 moles. So, therefore, the final conclusively the answer will be in the percentage. So, percentage moles of Fe +2, that is equal to how much you got? 0.79 divided by, it is your 0.93 into 100, and if you see the percentage moles of Fe +3, that is equal to 0.14 divided by 0.93 into 100. So, this is basically the percentage of mole of Fe +2 and Fe +3. So, it is a nice question, came once in JEE Advanced. So, next law of reciprocal proportions, what it states basically. Now, we have to focus at that 3 elements, let us say carbon, hydrogen and oxygen. I am taking 3 elements under consideration. Let us say CH is making a simplest compound, let us say CH4, and carbon dioxide is CO2, and HO if can combine it is giving H2O. So, that means why I am writing so many compounds and elements, because the statement was that when one element combines with 2 other elements with its fixed mass, then the combining mass ratio of the other 2 elements will be equal, multiple or submultiple of the mass ratio of the other 2 elements when they combine to give a compound separately. So, that means I mean to say that when C and H is combining to give you CH4, here carbon is 12 gram, hydrogen is 4 gram. In case of CO2 it is 12 gram, it is 32 gram. So, what is the mass ratio of hydrogen by oxygen? You can check it out, that is basically 4 by 32, that means 1 by 8. Now, I said that when H and O independently make the compound, then it is H2O, and then mass ratio of hydrogen by mass ratio of oxygen is again 2 by 16, that is 1 by 8. Just look at, they are equal. So, that means what? I mean to say, when hydrogen and oxygen combine separately is giving H2 compound whose mass ratio is 1 by 8 may be equal to the mass ratio of hydrogen and oxygen when it was making the compound with 12 gram of carbon. So, 1 by 8 equal to 1 by 8. Next example, if we say same 3 elements, different compound, let us say C, H, it is your O, let us say it is like this. Let us say I am talking about it is H2O2. This is, let us say, CH4, let us say it is your CO2. So, now again it is 12 gram carbon combining with 4 gram hydrogen and 12 gram carbon, it is combining with 32 gram oxygen. So, the ratio of mass of hydrogen by mass of oxygen how much? That is basically equal to how much? 4 by 32, that gives you 1 by 8. Yes. So, now if I talk about the hydrogen oxygen combining separately. So, what is the ratio? Mass of hydrogen by mass of oxygen, that is equal to 2 by 32, that is equal to 1 by 16. Now, how we can correlate with 116 and 18? It is basically if you multiply this with 2, then you get 1 by 8. So, that means this 1 by 16's multiple is 1 by 8. Again similarly, initial case it was equal, now it is multiple. It can be sub-multiple. Suppose I get the fraction instead of 2, then it is sub-multiple of the mass ratio of the elements, hydrogen oxygen going to be equal to the mass ratio of the fixed mass of carbon. So, this is law of reciprocal proportion. It is fantastic law. It gives kind of idea of law of equivalence. Later on we will see. So, we are seeing that law of multiple proportion, law of reciprocal proportion, etc., based on basically the Dalton's atomic theory. In any case, Dalton's atomic theory is not violated if we do not take the flaws. If we take the flaws, yes, it is violated. I should say that it is not the end. We will have to continue again with this chapter. Till then, study well, solve the questions. Goodbye.